Hi everyone, welcome to the next review video for Earth Science. This video is going to be a little bit different considering the current circumstances. So this is going to be a fresh take on the topic. This is Unit 7, which is focusing on weathering, and this video is just going to focus on physical weathering. Alright, so here we go. Number 1, so weathering is going to be the physical and chemical processes that change rock. So like I said, today we're just going to focus on the physical version of it. But generally it's a way of breaking rocks down into smaller pieces, as you can see from these two landforms that are formed through weathering. In order for weathering to happen, there's got to be air involved, water involved, or humans or animals. So the air would be like something to do with the wind maybe, and the water would be obviously rivers or oceans, and then humans could break rocks down, and then animals can like burrow into the ground. Something interesting, if you've noticed, the moon has craters. That's why they say the moon looks like cheese, right? It's got all those craters everywhere. The reason that the craters are there is because there's no atmosphere to move any of the dirt and fill in the craters. There's been a lot of impact craters that have happened on the Earth, but all of them are gone for the most part because the wind and the water fills in those holes. So since there's no weathering on the moon, there's still craters. So what are physical properties? They are anything you can observe with your five senses. So anything like color, shape, mass, density, anything that you can physically see is going to be considered a physical property. And these are the things that we're going to be talking about in this video in particular. So a physical change is when you change the appearance or one of those physical characteristics of the material. So you're actually not changing the substance. You're not changing like the rock into paper, for example. You're just breaking the rock. It's still the same rock. It's just broken. So here's some examples. So melting something. So like if you were to melt an ice cube into liquid water, it's still water. That's why I wrote on the bottom, any phase change is considered physical. And also breaking and cutting. Alright, so in terms of just physical, so we're going to break the rocks down into smaller pieces but not change the chemical properties of the rock. So it's still the same properties. So here's a question for you. It says, base your answer to the following question on the diagram below. It represents some sort of outcrop. An outcrop just means like a side view of like a mountain, essentially. They want to know which rock layer is the most resistant to weathering. So see if you could take like 2 seconds, pause the video, and see if you could take a guess. Alright, well, you've had no background knowledge on this, so essentially how you would do this is you would pretend that this mountain right here was actually like this at one point. So you could see layer 1 had this much go away, layer 2 had this much go away, layer 3 still good, and layer 4 had this much go away. So the most resistant would be layer 3 because it's still pretty much all there. Resistance means it's hard to break down. You might have known to not put anything that's glass and put in the freezer, because in this case they had some sort of drink they put in the freezer, and the water inside of the bottle expands when it freezes. So it obviously is going to be, the water inside's too big for the container when you freeze it, so it cracks. This is the first type of physical weathering. It's called frost action. You could also see it as frost wedging. We could put that in parentheses up here. And essentially what happens is water gets into little cracks in rocks, and then at night it freezes, which makes the water expand, and it makes the crack a little bit bigger. And then the sun comes out and it melts the water, and then more water leaks into it, and then it freezes at night, expands, and the crack gets bigger and bigger and bigger. So the key factor for this to happen is you have to have it freeze at night and melt during the day, because you need it to melt and freeze over and over again to get more water to be added to make the crack bigger. There's a little picture for you. Whoops. And potholes are a really, really good example of this happening. So in New York, we have a lot of this happening here. Gets cold at night, like below freezing, and warmer during the day, above freezing. The second form of physical weathering is called abrasion. This is when you have rocks that are hit into other rocks. Like if you take a handful of rocks and throw them at another rock, that would be considered abrasion. But the throwing action happens from like the wind or the water. Like in this picture over here, the little sand particles here were pushed into this rock and it creates this crazy pattern. So abrasion is rocks hitting other rocks. So generally it smooths the rocks out. So you could see in this picture by the water, the rocks are all nice and rounded and smooth because water tends to do that. It chips away the edges. So for example, if you have a square and another square and you put them in a container and you shake them up, eventually what's going to happen is the edges are going to be chipped off. And if you chip off the edges of a square, I'm not a very good drawer, but it starts to like round out a little bit. And this happens over and over and over, so it would chip off these corners next. And eventually it would end up with a circle, like in this picture. This is a picture of a sandstorm. All those sand things are particles, and as they hit into things, it's going to cause abrasion. Yeah, so this was just saying the rocks break off the sharp edges, making them round. This is just a little picture. If you see wind-driven sediment, these are just little sand particles. And the wind's coming from this way. All the sand particles would bounce off the ground and hit the rock over here. So eventually, the rock would look like this. The sand chips it away right there. You can see where all of them are hitting. So rocks that are weathered by water become rounded, smooth, and smaller. They're going to become smaller because you're chipping off those edges, so they're not going to have as much mass. An example of water and wind. We call things that are getting hit by wind erosion or wind blowing particles into them, they make these holes in the side of the rocks like this. This is called pitted. It's called a pitted texture from wind. So animals and plants, tree and plant roots grow and split rock. So even if the rock is crazy in terms of its hardness because it's got minerals inside that are really, really hard, a plant root can still grow right through it and break the rock like in this picture. So essentially, the inside of the rock is now exposed to the air. This was never normally exposed to the air because it was inside the rock, right? So now when it rains or something, the water will get in here and on the outside. So it makes the weathering process actually happen faster if you break rock apart. A couple pictures of plant action, root action, plant activity, you might hear it as. They sort of put these metal plates in sidewalks to prevent this from happening, from destroying sidewalks. Like if you have a tree, the metal plates prevent the roots from going under the sidewalk, breaking up the sidewalk. So animals are also a cause of weathering. They dig burrows and loosen the soil. And one of the last ones is called splitting. So this is just the fact that things expand. So the rock actually has molecules in it. And if you heat it up, the molecules spread out. And then when it cools down, the molecules contract or come back in. So when you have a big piece of rock that's expanding during the day and contracting at night over and over and over and over and over, it breaks the rock naturally. So you can get a huge rock like this to break right in half because it just expands and contracts, expands and contracts. Again, you can see some ducks or birds on there for scale. That's a really big rock. The Hulk did not break that rock in half. That was from splitting. The rock expanded and contracted over and over again until it couldn't take it anymore. It just cracked right in half. So this page might look familiar, but which mineral on the reference table chart do you think is the most resistant to weathering? Well, you would go to the hardness, and the one with the highest hardness is going to be your most resistant, so quartz or garnet are going to be your answer to that. This is another question like the one we did before. Which rock layer appears to be the most resistant to weathering? See if you can figure it out. This one's really weird. Okay, well, you have to look at the sides of these squares here. So this one here, E, you see how it goes straight up and down? D goes on a slant, C goes on a slant, B goes on a slant, A is pretty much up and down. The ones that are most up and down are the most resistant, so because they didn't really break down. So straight up and down equals most resistant, and on a slant is the least resistant. So again, if you're confused, like if you look at layer B right here, look at this side. See how it's on an angle? That means it's least resistant. But look at E. See how it's up and down right there? That's going to be most resistant. So E is going to be most resistant, and it looks like A and let's see. So B is definitely not. So B is out. E is good and A is good. So it looks like D is going to be your best answer. Because letter D here is on a slant more. So it's just another way they can ask a resistance question. Alright, let's see if you can do these. Identify the name of the largest particles that can be transported at point A when the stream's velocity is 100 centimeters per second. So for this question, you're going to use the page 6 particle size chart. That is this one over here. So what's the name of the largest sediment that can be transported at point A when the stream's velocity is 100 centimeters per second? Alright, let's see how you did. So if you go to 100 centimeters per second right here and you go all the way up to the black line, right here, you're in the pebbles category. So that's the answer, pebbles. Number 62, describe the relative changes in the velocity and the rate of erosion that will occur after 2 days of heavy rainfall. So if there's a lot of rain, what do you think is going to happen to the stream velocity? This is speed of the water, and the rate of erosion is going to be how much material is moved. Remember, erosion means to move. So what do you think is going to happen to the speed if there's heavy rain? The speed should go up. What do you think is going to happen to how much material is moved if there's heavy rainfall? Well, if the speed's going to go up, there's going to be more material moving, so that will go up as well. Explain why rock particles transported by stream often become more rounded. The answer is because, if you remember I drew you a picture, the edges get chipped off by abrasion. Alright, a couple more. A stream moving at 1 centimeter per second here can move which of the following particles? So see if you can get that. Alright, 1 centimeters per second. So you go to 1, go up to the black line. So we're here. So it's going to be able to move sand and anything lighter than it. So it's going to be sand, silt, and clay. If something can move a big piece of particle, it can also move things that are smaller than it. Think about it. If you can lift up a brick, you can lift up a feather. Sand, silt, and clay. I can't write. There we go. How fast should a stream be moving to move a particle measuring 0.5 centimeters in diameter? So I'll give you a hint. 0.5 is going to be in between here. Here's 0.1, so this is going to be 0.2, 0.3, 0.4, 0.5 is like here. See, diameter. So there you go. I gave you the 0.5. So how fast should a stream be moving to move a particle measuring that big? Alright, so you got to go all the way across until you hit the black line. You always hit the black line. So we're right here about, and then you got to go straight down. So I would say anywhere from, this is 10, 20, 30, 40 to 60 is the range for that one. 40 to 60 centimeters per second for the speed. Boulders have a diameter of, look at particle diameter. Go to boulders. Here's the category of boulders from here and up. So the minimum is 25.6 or larger. Alright, well, thank you for joining me for physical weathering. I know this is weird that you're learning everything online now, but at least we got this. If you have any questions, feel free to email me. And you can watch this video as many times as you want. Pause, write down little notes, anything you want. Alright, I'll see you on the next one. Bye-bye.